Hey, what's up guys? Today we're going to talk about equalizers and the process of equalization. First of all, this is an equalizer. Secondly, the process of equalization is the utilization of an equalizer, which is a network of electronic components that adapt or modify frequency response of a signal source. So what's really exciting about this is the EQ is an everyday process of how we manipulate frequency in both the pre, as we're tracking, and the post. EQ is actually applied to a lot of different components. So like if I have a guitar amp that has EQ on board from the source, even my guitar has a tone knob that adjusts equalization in general coming out of the guitar. A lot of other devices have EQ on board. But once we get in through our mic and into our preamp, a lot of preamps, or if we're using a console, have available EQ to use while we're tracking. And then, of course, once we get in the box, into a DAW, and into a system like Pro Tools, we have access to plenty of equalization in the post. There are a few specific parameters about equalization on board an EQ that are very important to know and very easy to understand. The basic ones are gain. If I turn my gain up, we call it a boost. If I turn my gain down, we call it a cut. In some situations, we'll call it attenuation. Additionally, when we use the filter types that boost and cut, the filter type that boosts is called a peak, and the filter type that cuts is called a notch. Additionally, we also have frequency. That is at what frequency point we're actually going to manipulate the source. So an EQ, again, is a series of electronic components that manipulate and modify frequency response, but we actually have to choose which frequencies. Additionally, we have Q, which is the bandwidth or range of how much frequency around the frequency center we actually adjust. So what other frequencies are being adjusted around that? So if we chose a 1K frequency as our main frequency center, we can actually adjust the Q so that it's either real narrow around just 1K and its neighboring frequencies, or we can make it real broad so it approaches a large range. That is Q. Now let's talk filter types. Filter types are really exciting, but they're very specific to parametric EQs. On a graphic EQ, we had faders that were the same at each frequency spot, but they were just assigned to different frequencies. And once we get into a parametric EQ, we actually have filter types or filter locations spread throughout the frequency band from 20 hertz to 20,000 hertz. The first parameter we're going to look at is the high pass and low pass filters. Okay, so also known as low cut and high cut. The high pass and low pass filters do kind of what they say. In the frequency band, we start from 20 hertz and we go all the way to 20,000 hertz. And the high pass filter allows us to choose a select point in the frequency where anything below it is cut and everything above it is still allowed to pass, and hence the high pass. A low pass filter is the exact opposite, and instead it allows our lows to pass and it cuts everything in the high. When we put them together, we call that a band pass. So when we're bringing those in together, we call it a band pass. These are not just unique or specialty items. These are things that are used on a daily basis that will always be used by you once you bring these into your arsenal of use with your track. So let's just take a couple look at those examples. So the high pass and low pass filter. This is the high pass filter with our high pass filter symbol and our low pass filter here and on the SSL EQ. And the same representation exists. I mean, it looks a little different, but if we go over to the 7-band, HPF, LPF, high pass, low pass filter, we could change the Q, which is in this instance is going to be a dB per octave slope. Activate those and roll them in so you can see them. And you can definitely see their shape, because what we're doing is we're literally, with the high pass filter, we're going to cut off whatever is happening at that frequency range. In this instance, it's 153. We can make adjustments, to that. And then for the low pass, we have the exact same situation. So anything on the other side of that, we can eliminate. Additionally, we go over to the SSL EQ. Again, this is one of my favorites, mostly because of just the clean, easy use of it. Notice there's no slopes. It has a fixed slope. And as we listen to the audio, we can actually roll off some of the unwanted stuff, and by rolling it off, we actually eliminate unwanted bleed from the kick. So let's just say we get near 200. Same thing with a high. A little too muffly. Open up a little bit. And there we have our filter, our high pass and low pass filter, and how we would use them just to shape that overall sound. Our next parameter is the mid-peak notch. And we have a peak and a notch right in the middle, peak being a positive or boost and notch being the cut. And this is in the middle of the spectrum typically, but it can be used anywhere in the range. But the focus with these is we get to actually attenuate very specific frequencies, and then we either get to boost them or cut them, and then we get to select the range of which they're used. So we have, of course, the peak notch filter, but then in that parameter, we have gain, which is either positive or negative. And then we have the frequency selection, which pinpoints where in the band. And then our last option is Q. Q is essentially the shape of how much in the band is going to be affected. So we can really tighten it, or we can really widen it to a bell curve. And you'll see that here. So as we go here, we can look at this. We're going to go into any one of these mid band options right here. But let's just say we pick our very mid section here. So I'm applying gain, and now I'm going to shape with Q. Okay, and then you can select at what frequency. So you can really very specifically isolate like what you're aiming for in that target range. Additionally, if we go look at this over here on the SSL, it's the same thing here. When we look at it here, here's our high mid frequency. We know it's a peak notch because it's typically in the mids, and additionally, if we have the Q option, that really specifies like what we get to do with it, and you can see we can either widen it or tighten it. We can select our frequency and you can go up or down. The big key here is that in order to use this effectively, we have to know what kind of frequencies we either want or don't want. What I always like to suggest to people who maybe don't know exactly what frequencies to use or which ones to focus on is to go through the band, sweep through the band, and by using the process of elimination. So if I'm looking for what problems do I have in the overall frequency band, what I like to do is boost immediately with the gain and then sweep to find what sounds terrible. That's where I'm going to cut it. In the opposite form, if I'm looking for something to sweeten up my sound, I'm actually going to cut or take it down to a negative gain and sweep again and find out when I don't like it or what I feel like it's taken away that I need. So let's take a look at that kind of option here. By process of elimination, a lot of times that we find out that the things that we don't like are kind of highlight exactly what we do need or do like. So like in this instance, what I'm going to do is I'm going to search with my high mid frequency to find an annoying issue, like a real actual problem in the source. And so what I'm going to do is I'm going to boost it, and then I'm going to leave it moderate, and I'm going to sweep the frequency band to hear, preview, see what it's like. Now, from this, we can hear that ringing. This is where that ringing tone from the snare comes in. And whether we like it or we don't for that particular instance, it's a wood snare, so I actually don't prefer the ringing. So what I'm going to do is I'm going to dip that out. On the low mid filter, I'm going to do the opposite. I'm going to cut, right? Negative dB on that side, okay? Then I'm going to sweep the band. Kind of noticing there's a loss there, so there's a deficiency there. So what I'm going to do is I'm going to boost that just a little bit. and then open that up. Take a look. All right, and then open it up to everybody else. There's some of that boosting, of course. You have to remember that when we EQ stuff, we're actually applying gain somewhere. By applying gain, we're actually putting in more volume in certain frequency bands. You can see it. There's a lot of gain right here, a little bit of gain right here, a lot of gain right here. So we do have to be mindful of what that's doing on our output as we kind of process it through there. And we can modify that further along down the chain, but we do have to be mindful of what it's doing to the overall sound. Now, truly, in the modern day era of plugins, a little bit of clipping is actually good most of the time to give it a kind of saturation. So we're okay with a certain amount of or a certain degree. Let's open it up with everybody else. Okay, so our last really cool parameter that I really enjoy are the shelves. We usually talk about this as a high shelf or a low shelf. The shelf just means that we make an adjustment, and whatever frequency we select, it's actually going to create the shelf shape, and it's going to go to the end of the spectrum with that gain adjustment. So if I do it as a high shelf, we look here, we can easily see it. If I do it as a high shelf, and I boost, let's say in this example, I'm at about 6 dB, and I'm going to pull it back to 1K, it's going to go all the way to the end of the spectrum as a boost. The brilliance of this is that normal sounds, normal sources actually tail off very naturally on their own. And because they tail off naturally on their own, even though we have a boost that goes from 1K all the way to the end of the spectrum, when it gets to the end of its spectrum and it starts to tail off, we don't have any really unnatural things taking place because it rolls off nice and gently on its own. If there were problems or issues, we could easily take them out. But that's what's nice and easy about this is we could really quickly make adjustments if we just need things either brighter or darker on both the high end and the low end, and we really get to do that with this shelving option. So let's take a look. Let me show this to you with this on. You just need a little bit more highs or a little less. Let's bypass this now. Let's give it a little boost. Up here is our high shelf by default in the SSL. And you can pinpoint which frequency you want it to start at. In the low, same thing. For like, you know what, we want it to, you know, have a little more going throughout or a little less. We can do that and get away with it there. Additionally, on the SSL plugin, we actually have the option to switch to a bell, which is essentially the peak notch. And you can see it even down here below. We can see it right in this. It's kind of small here, but as we look at the Pultec, this Pultec EQ right here is a little bit different. It uses a kind of a quirky little methodology, but it's built and designed from a vintage era. In the Pultec, we actually either boost or attenuate, so either turning it up or turning it down, and we select a specific frequency. So let's say we picked the 60 hertz. You know, we could either boost it or cut it. And then same thing, if we switch over to this other side, the high frequency, we could go to like 5K and do the same thing. Let's talk a couple tips and techniques with EQ. First of all, smaller moves create bigger results, which means that by doing less, you actually get more power in your sound. Additionally, keeping your bell or cue in a broader stroke actually also makes the overall sonic quality smoother. So try not to have to do too much in a sharp zone. Now, sometimes you do have to do it real tight, so you try to minimize it, but you get what you need and you move on. Additionally, with EQing, we have to also remember that the Fletcher-Munson curve, the equal loudness curve, which tells us that as we begin to turn music up, we see an evening of the highs and the lows that does come into effect in the balance in relationship from one sound source to another. So let's just say I have a kick and a snare, and my kick and snare are even in terms of where they are in the mix. Then as I turn the overall mix up, I begin to hear more of their highs and lows. But in relationship to each other, as one of them is turned down compared to the other, we begin to lose both the high and low qualities against each other. So one of the big things I always talk about is like, while you're EQing, you have to set levels. And when you get your levels set, leave them and try not to go back and adjust them. Because what I see a lot of mistakes in mixing. I used to do it too, where like as you're further on in the mix, as you get down the line, you start going back to things that you already mixed and balancing or adjusting them. And as you move them, you actually create sonic changes in the EQ. So we really have to focus on making sure that we maintain that.